Today we're going to look at section 1.4 over imaginary numbers, also known as complex numbers. First, we're going to talk about what they are and what they look like, and then we're going to start adding, subtracting, multiplying, dividing those complex numbers, and then we're going to look at how to simplify expressions where the square roots have negative numbers underneath of them. So an imaginary number is something that can't be done in the real number set. When we take the square root of a number, we're looking for something that when we multiply it by itself, it equals that value under the radical. However, when that value is negative, there is no number that multiplied by itself will give you a negative anything. So we have to come up with a way to represent those values, and we use an imaginary unit. We're used to variables in math, but you'll notice that in any equations that we're solving, they don't use the variable I. That's because I actually has a value. It is representative of the value of the square root of -1. Which we know then in math that when we want to get rid of a radical, we can square it. And when we're talking about an equation, we have to square both sides. So if I equals the square root of -1, then the value of I squared is -1. This is a rule we're going to be using a lot today when we're simplifying expressions. A complex number is an expression that contains a real number, A, and an imaginary number, BI. This is what we consider standard form. Now for me, it doesn't really matter which way you write it. However, my math lab will always ask you to put complex numbers in standard form. So for today, we're going to get used to writing everything in A plus BI form. This right here basically is kind of like the same rules as like terms. It tells you that in complex numbers, you can always combine real numbers and you can always combine imaginary numbers. We're going to start with adding and subtracting. Adding and subtracting is not very complex. It's not very difficult because really the skill needed you've already accomplished when you learn how to add and subtract like terms and add and subtract polynomials. So we're going to treat these variables or these complex imaginary numbers very similarly to algebraic expressions and combine their like terms basically. However, we know in math that when something is inside parentheses, it's like in jail. It can't do anything. You can't combine anything in here with anything in here until those parentheses are gone. The only way to get rid of parentheses is to use, that's not how you spell it, that is to use the distributive property. So we are going to always distribute to get rid of any parentheses, no matter what we're working with. So to distribute here, there's a 1 in front. To distribute here, there's another 1 in front. When we distribute those ones, we're left with actually 4 straight terms. 5 minus 2i plus 3 plus 3i. Then because we want our answer in standard form, we're going to combine our real numbers first. 5 and 3 is 8. And then our imaginary numbers second. -2i and +3i is +1i. The bottom one reads 7 minus the complex number 2 plus 6i minus 6 times 12 minus 2i. You'd be surprised how many people think that this 7 is the multiplier, even though it's not. The multiplier is this -1 that's sitting directly in front of it. So we're going to get 7 minus 2 minus 6i minus 72 plus 12i. Then again, we want to combine our real numbers. 7 minus 2 is 5. 5 minus 72 is -67. And then -6i and +12i is +6i. You treat those i's when you're adding and subtracting just like terms. Multiplying is also not that difficult. We are either going to use the distributive property or the FOIL method. We know distributive property has something multiplied by something inside. FOIL method would be 2 complex numbers being multiplied together. Simplifying, remember that we're using the rule I squared equals -1, and then make sure your final answer is in standard form. So this would be a distributive property problem. 7i times 2 is 14i, and 7i times -9i is -63 I squared. Now they both have I terms in them, but we know one's an I and one's an I squared. If we can't subtract x's and x squareds, we're not going to be able to subtract i's and I squareds. But we do know that negative, or I squared, sorry, is representative of -1, and since 63 and I squared are multiplying, we will multiply those together, which gives us 14I plus 63. That is our final answer. However, like terms, or sorry, standard form means you would have to switch that. This example we're going to skip for the time being. We'll come back to it. This problem would be a FOIL problem. Remember, FOIL stands for first, outside, inside, and last. So our first terms are 5 and 6. That gives me 30. My outside terms are 5 and -7i, which is -35i. My inside terms are 4i and 6, which is +24i. And my last terms are 4i and -7i, which is -28i squared. We've multiplied, now we need to simplify. So my I terms that are being added and subtracted on the inside can combine to be -11i. And -28i squared means -28 times -1. That gives me 30 minus 11i plus 28. Combine my real numbers and put in standard form, I get 58 minus 11i. We will go back to the next example here in a minute. Usually people do well with addition, subtraction, and multiplying. It's dividing that they tend to have a little bit of an issue with, simply because when the directions say divide, people want to divide. However, when we are dividing by a complex number, which means the bottom of our rational expression will be a two-term complex number, have a real number and an imaginary number, we're not actually ever going to divide. We are actually going to multiply. But what we are going to multiply by is something called the conjugate. The conjugate is the opposite sign of the complex number. So if you're adding in the complex number, then the conjugate you will be subtracting, and vice versa. Now the reason why we're able to do that is because this I down here represents a radical in the denominator, right? I is the square root of -1. In math, you're not allowed to have a radical in the denominator. You may have remembered something called rationalizing the denominator when you're working with radicals. That's what we need to figure out how to do. So go back to this slide that we just left, the example that we skipped. These two are conjugates of each other. They have the same real number and imaginary number, but one's an addition, one's a subtraction. Let's FOIL this and see what happens. We get 4 minus 14i plus 14i minus 49i squared. Do we agree that these middle two terms are opposites, which means they will cancel? So we're left with 4 minus 49i squared, which we know I squared means -1. So, sorry, that should be 49, not 48. So when these multiply, I get 4 plus 49, which gives me 53. So the conjugates will allow that imaginary unit to disappear. That's what we want in the denominator. So we're going to identify the conjugate of the denominator and multiply both the top and the bottom by that. So the conjugate of 4 minus I is 4 plus I, which then gives me two multiplication problems, one on the top, one on the bottom, and we then need to simplify. We move this out of the way. So we FOIL the top, we should get 20 plus 5i plus 16i plus 4i squared. On the bottom, we're going to get 16 plus 4i minus 4i minus I squared. Simplify what we can on the top. My i's can combine to be 21i. And positive 4i squared, remember, is 4 times -1, which gives me -4. On the bottom, my middle two terms will cancel. So I have 16 minus I squared means minus -1, which gives me +1. So that's going to give me 16 plus 21I over 17. To simplify this, we are always going to separate the two terms in the numerator over the common denominator, and then simplify the fractions. Neither one of these fractions can simplify, so this is my final answer. Okay, the very last thing we're going to do is talk about the square roots of negative numbers. Now there's plenty of rules of radicals. Some simple ones are that two radical terms can combine the radicands, which are the numbers underneath, and multiply them. Okay, which also means that any number under the radical can be separated into two separate radicals, as long as they multiply to give you what you're starting with. Some rules of addition and subtraction is that in order to add, the numbers underneath have to be the same, and you combine the coefficients. So the square root of a plus the square root of a means you have 2 square root of a's. 3 square root of a minus 4 square root of a means you have 1 square root of a, and so on and so forth. So the square root of negative b means the square root of -1 times the square root of positive b. Well, we know the square root of -1 is the same thing as I, which means every radical with a negative number underneath of it can be expressed in what we call terms of I. So the square root of -7 can become the square root of -1 times the square root of +7, or the term I radical 7. This is something we are going to do every single time we see a negative number under a radical. So we're going to simplify these problems, which means we are going to have to learn review how to reduce a radical and leave it in radical form. So start off, express all square roots of negative numbers in terms of I, simplify the square roots, and then simplify the entire problem. All right, so example 1, they're wanting us to add these two together. We can't do that because of several things. One, these numbers aren't the same, as well as our negatives. So the first thing we're going to do is take that negative out. It's going to come out here, and when it comes outside, it changes to an I. We're going to do the same thing here. Take this radical out, and it becomes an I. Next thing we're going to do is reduce our radicals. So our coefficient of 4i is going to have to multiply by the reduced form of the square root of 27. To reduce a radical, we are looking for two separate radicals that still multiply to give us 27, but where one of those numbers is a perfect square and the other number has no other perfect square factors in it. 27 is a simple one to simplify because there's only one option, 9 and 3. Okay? We're going to do the same thing with the next term. 3i is going to multiply by the reduced form of the square root of 48. The square root of 48 could be 2 times 24, but neither one of those are perfect squares. It could be 4 times 12. 4 is a perfect square, but 12 also has another perfect square factor of 4 in it, so we'd have to reduce that radical then. So that's not the one we want to use. Another factor pair is 16 and 3. 16 is a perfect square. 3 is prime. It has no other perfect square forms in it. So 4i is going to multiply by the reduced form of this. The square root of 9 is 3 times radical 3. Do the same thing for the next term. The square root of 16 is 4 square root of 3. Then we can multiply our coefficients. 4i times 3 is 12i radical 3. 3i times 4 is another 12i radical 3. Now we have coefficients that are like terms, and we have radicands that are like terms. 12i radical 3 plus 12i radical 3 means I have 24i radical 3. Okay, example 2. I want to remind you of a rule. When we're squaring something, it means whatever's being squared is getting multiplied by itself. So 2 squared means 2 by 2. X squared plus 2 squared means x squared plus 2 times 2. Anytime we have a binomial squared, the entire binomial is being squared. So we have to take a plus b and multiply it by itself. So this entire sum is being squared. So this entire sum here has to multiply by itself. But we also have to worry about this. So that I has to come out. So that becomes negative 2 plus I radical 3. And now we're going to square that. So the same thing will multiply by itself. Then it just becomes a FOIL problem. Negative 2 times negative 2 is positive 4. Negative 2 times I radical 3 is negative 2I radical 3. We get the same thing on the inside terms, negative 2I radical 3. And my last terms, I radical 3 times I radical 3. We multiply the i's and we get I squared. We multiply the radicals and we get the radical 9. And then we can simplify. Radical 3's that are being added and subtracted in the middle gives me negative 4I radical 3 plus I squared is negative 1 times radical 9, which is 3. We get 4 minus 4I radical 3 minus 3, which simplifies to 1 minus 4I radical 3. One last one here. Again, we've got this negative under the radicals, so we're going to take that out. And then we want to simplify. But right now, I can't add in the top. There's nothing in the bottom besides a 2. So to simplify, I'm going to start by separating my two terms in the top into their own fractions, and then I'm going to simplify the fractions separately. Negative 14 over 2 reduces to negative 7. I radical 12. I is going to get multiplied by the reduced form of radical 12. And that is going to be 4 times 3. Which the square root of 4 is 2. So we have 2 radical 3 there. Times I is going to give me 2I radical 3 over 2. And then my 2's can reduce. So my final answer is negative 7 plus I radical 3.